Right, so our lecture today is in two parts, functions in pseudocode. Of course, that everything in computing is related, but we'll treat them as sort of two different ideas. The idea of functions, little sub-programs or subroutines, and the idea of pseudocode as being a way of representing our algorithm aside from using flowcharts or English. So going back to the start of our course, we did talk about these things here. A program has control structures. The three main control structures that we're interested in is the idea of sequence, and sequence is kind of built into the architecture of the computer. And you might remember that with the Van Neumann architecture. Van Neumann architecture works with the fetch, decode, execute. And so every execution of a what do you want to call that, instruction to the computer is first stored in a place in memory, then loaded up into the very small temporary memory in the CPU, one instruction at a time. So it takes the instruction, decodes the instruction, then executes the instruction. So what that means is that the program is going to be executed one line at a time, right? So the line above will be executed before the next line, before the next line, before the next line. So the order that they are presented is the order in which they will be executed. Now, we do have departure from that, where we have selection. With selection, what we can do is we can go to a different place in the code. And so we do that with an if, then, else structure. So that's our selection. And then the other thing that we can do is that we can have a loop. And a loop is kind of related to that if, then, else, because it has a condition as well. So we talk about conditions. The conditions are going to be that part of the if, then, else structure. If some condition is true, then we do this. Else, which would be if the condition was false, then we do something else. And we do that in a while statement as well. While some condition is true, we go and do a bunch of code. And so that will bring us into programming. Okay, now you will have seen something like this, I hope, in your mathematics. So, you know, you'd be familiar with the idea of a function in mathematics where you can substitute a value for one of these variables here. These are mathematical variables. And so, for example, you could substitute the number 1 for x, then x squared, 1 squared would be 1 plus 1, and then the result of that function would be 2. If you substituted the value -1, then x squared of -1 is also 1, right? And so the value is 2. So that's kind of weird. A -1 and a 1 have the same value. And you're probably familiar with that. Would give you a, you could graph the result and you'd end up with a parabola sort of centered around 0. You've seen those kind of functions, right? I'm not going to go into it too much more. You could have multivariable functions like this one for g. And so in this case, maybe x could be positive and y could be negative. You know, maybe one of them could be 0, and we get all kinds of numbers, which you could work out mathematically. Of course, a computer could do that for us very nicely as well. But the important thing that we notice is that a single variable sometimes, and sometimes multiple variables, are input into the function, and then what comes out is a single value. Multiple values go in, or single values go in, or maybe no value, but what comes out is a single value. And that kind of analogs with what we do in computing functions as well. And that is represented by this function here. What we see there is the z. The z would represent some output from the function. The function is going to be processed and it's going to give an output, which we're going to store in a variable called z. The function is going to take two variables, x and y, and it's going to process it. Now, when you see a symbol like this symbol, we have a rectangle, which you're familiar with in a flowchart. This is a flowchart symbol. You're familiar with the rectangle in the flowchart symbol, but this is a special rectangle. I hope that you see the two lines, sort of parallel lines on the edges. Those represent the fact that this is a function. And so a function is kind of like a little bit of a black box in this represented like this. What we mean is there's a function there that's doing something, but it's not explained in this box. So somewhere else we'll have to explain what's happening in that function. And that's what we would do in our flowchart. We'd have another separate flowchart, which would represent exactly what's happening in the function. So the function is kind of like a little program on its own. So you've got a big program that's doing a lot of stuff. And then inside that program, or called by that program, it can call other little programs. And those little programs we'll call functions. And to those functions, we pass some variables and we get back some result. Does that make sense? So that's how our function works. And so, for example, here's a flow chart that I hope that you can read. We've got 3 inputs happening here, 1, 2, 3. Those 3 inputs then are going to be processed in this. Now, the colors don't mean anything, as you know, but the shapes mean something. And so we've got a rectangle box there, and it takes those 3 inputs, which are assignment, quiz, and test, and it adds them together to give another value, which is the sum. So that's a process. And then we see that that sum value is then used by another process, which divides it by 3 to give another value, which is an overall value. And then we have an overall output. Now, what we've got is a setup that would work with a function. Now, why I say would work with a function in the way that we've just described it. We have some inputs, 1, 2, 3 inputs. We have some processing, and we have some outputs. That would work as a function, right? We have a single output, a bunch of inputs, and we can make that as a function. So the function actually shows up in the next slide. And so over here in the original program, we're representing the function exactly as a black box. I said, we could talk about black box. When we say black box, what we mean is we've got something, we represent it, and we can't see what's inside it. And we often use black box analogy for things that we do in computing. And it just means that there's something there. We don't know what's going on inside of it, or maybe we do know, but for this representation, we don't really care exactly what's going on inside that. All we know is that we get an overall grade out of those 3. Right? And how that happens, well, that's explained somewhere else. Well, where is that explained? It's actually explained over here in this other little diagram. So this diagram, it looks like another little program, right? So a minute ago, I said that a function is kind of like a little program that is called by another program. It's exactly what's happening. So in this program, we're getting 3 inputs. We feed those 3 inputs into this other little program. And then those inputs come over here, right? You see here, we're feeding these inputs in as assignment, quiz, and test. Then over here, in this, think of it as another little program, those 3 inputs come in, and the order that they come in is important, but notice the actual name is not important. See, here it's called assignment, quiz, test. Here it's called X, Y, and Z. Doesn't matter that they're different names. What matters is the order, all right? So what you should be reading this is first, second, and third. Now, I don't want you to get confused. These names are important. We can't just throw away the names. They're important because in this main program here, they are used, right? So we actually use the name assignment here. We use the name quiz here. And we use the name test here. So in the main program, they're used. But in this program, it doesn't even know them. All it knows is first, second, and third come in. First, second, third come in. What do? We create a new variable called S. What does S do? It takes first, second, and third and adds them together. And stores that value in S. Then the value of S is divided by 3, and the result of that is stored in a new variable called AVG. Then we return AVG. So when we say return AVG, what that actually means is that this little program, as we look at it here, is now finished. As soon as you can think of the return as a special keyword, which says to the computer, finish this little program. We started this little program here. Now we've finished it, but we finished it. It wasn't a waste of time because it did something. What it did is it gave us this value, AVG, which we're now going to return. And how we return it is in this statement here. Do you notice it says overall? When we use the equal sign in a flowchart or pseudocode or program, we mean takes the value of. So you can read it like that. There's a variable called overall. It takes the value of whatever is returned from the function called average grade with these 3 inputs. So that's what it means. So this means run that little program and get whatever comes out of it as the return value and put it in a variable called overall. And then the last thing we do is we print overall. We're going to be doing a little bit of that as we go forward, I hope. All right, so the inputs, as it mentioned in the previous slide, the inputs were assignment, quiz, and lab, I think. And then there was a single result. Now notice we had multiple inputs, but we only had one result. It's kind of the way it works with, for example, with Python, we can only have one output. We can have multiple inputs. You don't have to have 3 inputs. You could have 2 inputs. You could have 4 inputs. You could have 0 inputs. You could have 1 input. But yeah, for outputs, you don't have to have an output. You can just do a return. You have to have a return. Return is what says this little subprogram is finished. This little routine is finished. Only when it sees return. So when return comes, now we're finished. We could return a value or not. Anyway, so what I want to represent here, this is, I hope, I'm only going to show you this. It's not actually, it's not in the notes, so I don't think it's part of the course. So, I mean, if you want to have a sleep now is a good time, I suppose. The only reason why I'm mentioning it is I think it helps me to understand what's happening here. Maybe it'll help you. All right. So what happens is we have this concept of a stack. And so what a stack is in a computer memory, what we do is the stack is empty. Then we add things to the stack. And we call that pushing onto a stack, right? We push onto the stack. And then we push something else onto the stack. But the way the stack works is when we want to remove something from the stack, we have to remove it from the top. We can't remove this value until we remove this value. Does that make sense? Now, how it works in the memory is we actually use that for the way we run computer programs. So we go and we launch this computer program, which is to calculate the overall grade. And so we put that in there. This is the overall main program. It goes into the memory. Now, at some point in that program, it launches the little subroutine. The little subroutine calculates, right? So let's go back to the, we launch the program and these things happen. All of this is sitting in the memory at the moment, right? Here, all of this is sitting in the memory. Then when it gets to this, it's what it does is it says, well, I have to launch that little program. So I'm going to have to load up all of these instructions into the memory, create these variables, etc. Well, where am I going to do that? I'll push that onto the top of the stack. So at this point, we're going to do our average. So we got our overall, we got our average. Now, everything associated with average is sitting here. Everything associated with average is sitting there. So what's associated with average? S, AVG, XYZ, they're all associated with average. So they live here. XYZ lives here. There's no XYZ here, right? What do we got here? We got assignment, test, lab, right? There's no XYZ. XYZ only lives here in this little bit of memory. You with me? So all these things are living there. In this function is running and it's grinding away. It works. And when it gets to the end, what does it do? It returns. Return. You can think, well, what does return do? It returns to the program that called it. It returns to the program that called it. The program that called it was overall program. And so the program was going along and it got to here, jumped over there, started doing those things. When it's finished there, it jumps back to, not there, jumps back to the main program at the place where it left off. But when that happens, return closes this. Return does 2 things. Any value that is returned, in this case, the value is average. So it takes the average value and it returns it. And average value now is sitting in this, right? But it's got a different name. It's called overall, right? So it comes over here as overall. So we got a variable here now that's sitting in the memory called overall. It's got a value, which it came from this function. And this function now, as soon as it hit that return, boom, that function's gone. All that stuff is gone. No more X, no more Y, no more Z, no more S, no more AVG. All of that's gone. All we got is this thing called overall. And overall just happens to have the same value as average did. Does that make sense? So that's how our function works. So it lives in the memory not as long as the main program. It's called by the main program, goes into the memory. When it's done, it's like, go away. Thank you for that value that you gave me, that return value. I'm going to use it. And I want my memory back. And away I go. Does that make sense? Anyway, so I hope that helps me to understand it. Look, I got somebody here. Hi, sir. Yeah, what's up? Yeah. Maybe that'll help you to understand it. There's a lot of things in that. if we're doing a proper computer science course, which I guess we're going to start doing, because now we're the University of Doha of Science and Technology as of yesterday or today or something, then you're going to learn about the fact of the variables, global variables and local variables. Okay, it's not part of this course, but when you have that, think back on this lesson. if you didn't go to sleep while I was talking about that. All right, so as I said, it's not going to come up in our quizzes, but might help you to understand functions a bit better. I hope it does. So the inputs of the function, they are sort of, they're passed into the function by the main, but they only exist in those variables as long as the function is running. The end of the function, we got the return statement. The return statement is very important. That is the end of the function. And as you see, all of this stuff I was talking about in that other way, right? Referring to what's happening in the memory. So the flow of instructions, when it gets to the function, the function takes over, right? The instructions of the function take over. And then when the return goes, we go back to the main. And that's how that works. All right, so our example, we had X, Y, and Z. And remember what I was saying here, X, Y, and Z only exist in the memory as long as that function's running. As soon as the function's gone, they're gone. Before the function runs, they don't exist, right? They only exist for that time while the function is working. The actual variables that existed before, they would still be there. Quiz, assignment, test, those values would be there. But X, Y, and Z only exist in the function. All right, so let's do it, I suppose. What do I mean by that? Let's see if we can, we saw this, rather than me draw it out again, I want to do it in, I think I've actually got it on this computer. I want to do this in Python. I think I might actually have it in Python. So let's see, which will save me some coding. And be careful what you type, right? So let's run Python, not this, diagrams.net. Didn't want to do that. Oh, sorry. This is not what I intended to do. I'm trying to run Python. What's going on? Maybe if I put on my glasses, it'd be better. Oh, there it is. It is running in the background there. So maybe I can find that. So there we go. Average of 3. Average of 3, or no, it's add 3, I guess. Now let's calculate the average. So we've done this one before, right? So it must be average of 3. Yes, this is it. All right, so let's have a look at it and see. So maybe we can see, strange naming convention that I had on this. My apologies on that. But maybe you can see some similarity between what we've got here in this Python code and what we've got going on here in anyway, so maybe you can see it better, but what we've got, so this bit here that I'm going to highlight now, that is our function called average grade. So I hope that you can see that. What comes in is the 3 values, X, Y, and Z. So that's the same as this X, Y, and Z. Sorry about the smallness of it. I suppose I could make it a little bit bigger. Yeah, just while we're looking at that, make it a little bigger there. Sorry, wrong arrow. All right, so I think you can see that. So this is what we're doing here. This is this. Now, DEF stands for create a function in Python. It stands for create a function. So we're creating a function called average grade, same as this. We're bringing in the variables X, Y, Z, and then we're doing this. We're creating a variable called S, and we're putting X, Y, and Z to it. We're creating a variable called A, and we're dividing it by 3, dividing the S by 3, and we get that. Now it says return A. Return, here I called it average, right? So then we got the main. The main is this thing over here, the main program. So what happens in the main program? Do you see we've got get the test, get the, well, they're kind of out of order. I'm sorry. One of these should be assignment, not quiz, but you know, same idea, 3 different things. We get those 3 things. And then what do? See this black box? The black box is the same as this thing here, which says make a variable called, I called it average. They called it overall. Make a variable called average. And what average is going to do is we're going to launch the function called average grade, which is defined up here. The DEF stands for define. We're going to launch that. We're going to pass these 3 variables. And remember, the names aren't important when it gets to here, right? What's important is the order. Now, when I say the names are not important, we can't just put any random names. We have to actually have values. And so there must be a test, there must be a quiz, and there must be a lab. But we could have called them something else. We don't have to call them X, Y, and Z. It's better that we don't call them X, Y, and Z because they're going to get changed inside there. Sorry, you're going to ask me something.
So for the 2 and 3, we just make it one function, or we supposed to make it separate?
You could make it one function. That's good computing thinking. Yeah, so you saw a pattern there and you could make it one function. You could do all this in one statement. Yeah, you could, absolutely. Good way of thinking. I like that. So yes, you could make that. The only reason why it's doing here is I'm trying to follow that our program, it works the same as the flow chart. And so the black box here is represented by this, which is a call of the function. Now, the only reason why I'm showing you this is I want to prove to you that this thing works. And so how we're going to prove that is we're going to run it. I think it said to take, they had some values that we were supposed to try it with, right? Or not? Should, no. Yeah, here. We're going to try it with the values 80, 90, and 73 and see if it works. Now, it should give us a value of, I don't know, you work it out. 80, 90, and 73 plus 90 plus 73. So that's 170 plus that is 243. Am I right? 170 plus 243 divided by 3. Okay, so that's going to be 81, right? So we should get 81. Let's see if that works. Let's run it. So the first value was 80. Then the next value is 90. Now notice the other thing is the numbers. We'll come back and look at those in a second. 90 and then 73. So why we're going to look at those numbers is I hope that you can see that those print statements, they're not just sort of randomly positioned all over the program. They're in a particular place, right? So the first print statement. So we see a print at line 2, line 3. But look, the program doesn't start at line 2. It starts at before or after line 2. Line 2 is up here. Where does it seem to you? What's the first thing that you see happening in the program? Yeah, I mean, it's starting here. The program is starting here. That's why I've labeled it the main. Here, all we're doing is defining the function. The function is defined. The function doesn't happen. It doesn't go into the memory until we call it. This is where the function starts, right? It starts there. So when we get to line 7, what it does is it launches that function. It passes these 3 values into it. They come into the function as X, Y, and Z, and then it starts working, right? And so that's why at before we get to line 7, all we're doing is showing 4, 5, and 6. Then we get to line 7 and we see, hey, all of a sudden we're in line 2, 3. This is line 2, 3. All of a sudden we're here. And we've already calculated those things. See, we've calculated S and we calculated the average already. And so inside the function, that value for the average exists. But then that value for the average, A, is going to be returned out of the function. Where to? It's going to be returned as the average according to this statement. And then the next statement is we actually print it. And so we see that. So the very last line of code, the average is 81. This 81 came as the output from this function to here. There's the equal sign there means take the output from that function and put it into this variable. Does that make sense? That's how it works. That's how you should read it and understand it. So going back to the memory idea, the memory started loading up all this stuff first. That was the overall program. When it got to here, And only when it got to here, then it pulled all this stuff into memory and started executing it, right? It's not quite exactly right. I mean, you know, it's all there. But what I mean is, I mean the memory closest to the CPU. I mean, it was all in the random access memory, but it pulled it out of the random access memory into the CPU only when we got to here. Then it goes up to the CPU and gets processed, and then we get this thing come out. And that's where we got that printout. I hope that makes something sense to you. Yeah, as I said, I hope it makes some sense to you. If it does, then you're well on your way to sort of understanding what's going on with our functions. And that's the break from that concept, because the next slides are about pseudocode. No, they're not. It's about, all right. So yeah, there is another couple of slides. This one is just that you should consider, why do we have functions? Well, why do we have functions? As I said earlier, a function is kind of like another little program, a little program inside a program. Right? And we call that program, and we just get the result from it because it's useful to us, and then we can forget about that. So it's that. Now, the thing is that with computational thinking, you see computational thinking, these words should be familiar to you. Decomposition, pattern recognition, abstraction. So you get the idea. So using functions relates to all those ideas, which are three of the four fundamental bases of computational thinking. So what we want to do is we want to break our problems down into smaller problems. And what are we going to do with those smaller problems? They will become functions or subprograms, subroutine, subprogram, function. What we want to do is we want to recognize patterns in our work. When we recognize patterns in our work, we see things that are repeated. Things that are repeated, they could each become a function. What we want to do is we want to abstract. We abstract from the more specific to the more general. So something, and that goes along with the repeating. So if we can see that, all right, I can add a test and a lab and a quiz result together and get the average. Okay, well, actually, I could abstract that, and I could just say I could add 3 numbers, and I don't care what those 3 numbers are, and get the average of them. And so I could use this function. It could be a much more general purpose function, which could just be average 3 numbers. So then I could use it not just for working out your average of your 3 test results. I could work out the average of 3 temperatures this week, or I could work out the average age of 3 students, or something like that. It would be a much more useful function than just this one that has a specific use that's only good for this particular purpose. So on that, what we find is if we have a general enough function, maybe it's something that lots of people could use. Maybe hundreds of people could use it, or millions of people could use it. In which case, if we do a really good job on writing that function, we could share it with the rest of the world. Well, we could do that by putting it into a library of functions that could be used by people in a shared way. Python is an open source programming language. And so all of the functions that are built-in functions of Python, they are available in libraries. This is really the, for Python, I'd say that's a great strength because it's been around for 10, 15 years and people, I think probably longer than that. It hasn't been around as long as Java though. But it's been around for quite a while, and there's been a lot of very useful libraries been built from it, for it. And so that means that people who are going to write little programs will find that, oh, I want to do something to give new instructions to my router on my network. I want to do something which is going to change some input to an operating system somewhere. Okay, you know, I could write a program to do that. Oh, wait a minute. Somebody's got this library that has that function in there, and I'll just get that. Okay, and so that's kind of neat. Now, that's for Python as a sort of a general purpose programming language. And what we find is we've got a lot of utilities sitting out on the internet, especially. The example that's given in our notes. Oh, well, sorry, I'm just running away with this, aren't I? Yeah, the example that's given in our notes is on Twitter. And the thing is that Twitter So their programming code, they're not going to let you see it. It's not like Python. You know, they're not going to share their code with you. But what they will do is they will sort of give you little plugins where you can have access to all of that wonderful data that they've got. You know, that could be useful to you in some way. And so they'll give you some a way of plugging into it so you can write your little Python program and sort of access their data in a special way to get some kind of report. And those little plugin things, we call them application programming interface, that a lot of these commercial sort of entities will do so that other people can develop, well, as I say, better statistics, etc. Now, the function, I sort of skipped over this, so maybe we should just go back to it. We've talked about that. All right, so how do we represent a function? That's what this is saying. Now, I hope that you noticed in that function that we had, we may have noticed this thing. So the function has a function name, it has some inputs, and it has a result. The result we called the return value. What is the return value of the function? The function doesn't have the body of the code. The body of the code was put aside in that definition area. All right, so here's an example of a header. What this means is, this actually means create a variable called A and call the function called average grade, passing into it as inputs X, Y, and Z, and the output, the return value, will be stored in the variable called A. And so that from that function, as it says, we can see that the name is average grade. We can see that it's got the 3 inputs, and we can see that it's got 1 result. And functions can only have 1 result. Does that make sense? All right. So let's see. We talked about that. Finally, get to pseudocode. All right. So that's the end of our little discussion on functions. You saw a function, just to sort of remind us of what we did see. You saw a function there in Python code. And so this is the function, how it looks in a computer programming language, specifically Python code. If you're doing Java or C# or JavaScript, it would be different. All right, but this is how it looks in Python code. Python code is kind of, I would say it's kind of elegant. There's a few things that you're going to see here that we do in pseudocode that's a bit more work, that actually represents how we would do a computer program in Java or JavaScript or whatever, that we actually can avoid some of this stuff. In Python, it's a bit neater because we've got things like this. We can put a colon in, which just means everything after the colon belongs to this bit of program structure. So again, we had our main program, the main program called the function. The function was defined beforehand. And after the function was complete, we had a value that was returned out of the function that we could use. So I think that's enough on that for now. All right, so the next topic, and this is our last topic for today. We only have 2, thank goodness. Pseudocode. Pseudocode is one of the three things that we use to represent an algorithm. So you've seen the others. I've had you drawing flowcharts last week, right? Drawing flowcharts. That's how we represent an algorithm. That's one way. Another way we do it is we just write a bunch of English, and that's another way. And so another way we've got this kind of looks like computing, looks like a computer code. Kind of. Another way of saying kind of is to say pseudo. That's what pseudo means to me. Pseudo means kind of. You know, so they'll talk about pseudoscience. Right? It's not real science, kind of science, you know, or whatever, pseudo, whatever. It's sort of like, but it's not exactly. Does that make sense? So yeah, pseudo news, or they call it fake news, right? Okay, no, it's not fake. Pseudocode is not fake. It's just if you put that into a computer compiler, it's not going to work. It's not going to work. Hey, but it looks kind of like a computer program, but it won't actually work in a computer. Does that make sense? So that's why it's pseudo. It's kind of like, but not quite. And so that's why it says it's close to an implementation, but it's, you know, we're not using it on a computer. So if you make little mistakes with your syntax and stuff, it's just the only thing that is going to use pseudocode is another person. And they're a lot smarter than a computer, right? They're going to look and say, oh yeah, I made a mistake, but I know what you mean. You know what I mean? Whereas if you write a computer program, the computer doesn't do that. It doesn't do, oh, you made a mistake, but I know what you mean. It just says, oh, you made a mistake. Doesn't work. Computers are not very forgiving. All right, so we've got some conventions. Now, when I say conventions, these rules are not sort of hard, fast, and global around the world. Different people would do it differently. We might do it differently next year. You know what I'm saying? I mean, so what we're saying is just to make it simple here for this semester at University of Doha of Science and Technology, what we're going to do is we're going to say we're going to use this way when we do our pseudocode, just to make it simple. All right, so to make it simpler, every time we have the name of a function, we're going to capitalize any words in that name, only the first letter. Anytime we have a variable, we're going to use camel case, which means we capitalize any second, third, or fourth name, but we don't capitalize the first one. All constants will be all caps, right? In our pseudocode. What else? Every time we use a constant or a variable for the first time, we're gonna identify what type the variable is. So here we're saying that we're creating a variable called my age, and the type is int. You don't have to do that in Python, but you have to do it in pseudocode apparently. So we got these different types. It's good for you to know these types because these are going to show up in the quiz on Wednesday. So you should know what int is, what float is, what string is, what char is, what bool is. So just in case you don't, right, int is a whole number, float is a decimal number, string is a bunch of characters all stuck together, char is a single character, bool means true or false, right? So yeah, you're going to use those. And so functions start with the keyword function. So we're going to use the word function now. That's different than Python, right? Python, we start with DEF. Define a function, DEF. In pseudocode, which is like programming language, but not programming language, we use function. Now, some other programming languages do use function. If you're going to use JavaScript, you'll have to state that you're creating a function. Average grade, that's the name of the function. Then there's our inputs. Because we haven't used them before, we have to specify what they are. Now, notice this thing here. We open up the block of code with a curly brace, and we close it with a curly brace. Every time we open the curly brace, we close the curly brace. This means that all of that is part of this, right? One curly brace there, one curly brace there, all of that is part of that. And what else we got there? We got some variables that we declared. Yeah, and we got the return value. Now, some other things that we do if we have a condition, this is different than Python, but this is the way we do it in Java, right? So if you're writing programming languages in Java, you'd have to do this. But we're not, we're doing Python, so we don't actually need to put those brackets there. But in our pseudocode, we say if brackets the condition, then we also use then. You don't have to do that in Python, but you do in Java, right? And then the open brace means, okay, well, we got lots of open braces here. Why? Okay, so this open brace means it comes after the then. So it means the stuff between these two braces is what we do if it's true. So if then else is going to if then else, the then is the true, the else is the false, right? So this is the stuff we do if it's true. This is the stuff that we do if it's false. Easy peasy. So that's our branching taken care of in our pseudocode convention. Now, we do a loop like this. We've got our condition, same as we did in the if then else statement. And then we use a while, okay, do. What comes after the do, between there and there, everything in there is what's going to happen if this condition is true, or as long as this condition is true, right? So this condition will be true maybe for several times. So as long as this condition is true, we're going to do this. Now, what kind of a loop would this be? Would this be a Sentinel loop or count? It might be a counted loop if we're, no, it's not a counted loop, is it? Because if it was a counted loop, we'd have to be changing the bill with a count, you know, -1 + 1. So this is a Sentinel loop, right? When the person inputs the number 0, then they stop adding bills. Does that make sense? Hopefully. Last semester when we did this, we had students doing all of that. I think that in the exam, we're going to do Python code. But last semester we had students do flowchart, pseudocode, and Python code. Sorry? Yeah. So we're learning at this time, but to be fair, because I don't want to lie to you, I did hear somebody say that we might not use pseudocode in the exam, but that's a might. Okay, we might not use pseudocode, but we might. We definitely, I think, are going to be using Python code in the exam. All right, so this symbol here can be problematic to some students because we look at it and we think that that means equal, like in math. It doesn't, it means a sign. It means the thing on the right is assigned to the value of the thing on the right is assigned to the variable on the left. Okay, so we have a variable on the left, we use the equal sign. Whatever's on the right, it's going to be assigned to that value on the left. So that's an assignment. If we want to check to see if two things are equal, is x equal to y? Then we use this one, double equal. That means is it equal to? Is it equal to? As opposed to takes the value of, or is assigned the value of. 1 means assign the value of. 2 means is it equal? And this means not equal. You can also use that. This is pseudocode, by the way, right? This means less than, of course, greater than, less than or equal to, and greater than or equal to. We can use all of those in our pseudocode. And that's it. Okay, so you guys lived through that. That was all right. It's almost an hour. We've got 2 more lectures, not lectures, 2 more lessons. We got 3 things to do. So we've got to do a tutorial, we've got to do a lab, and we've got to do a quiz. So 3 things. So my idea, and you just tell me if it's okay with you, I think it should be, is that we'll do the tutorial next lesson. We'll do the lab in the following lesson, but I'll give you some extra time. And the 30 minutes of the last lesson, we'll do the quiz. Sound all right? So you won't have the full lesson to do the lab. We'll have like an hour to do the lab, and then you can do the quiz. Sound okay?
Sir, can we do the quiz before the lab, if that's okay?
Do the quiz first?
Yeah.
Then students will do the lab before they think and leave early. The problem with doing the quiz first is that everybody finishes at a different time. So, okay, so I think that I'm flexible. I'm not saying no. If we did it that way, what I'd have to do is say, okay, start of the quiz is now, you got half an hour. Some people are going to finish in 10 minutes. They can't stay in the room with the people that are doing the quiz. So you tell me what you think of this. If we did the quiz that way, then I'd say, okay, you come back at, so the quiz would then start. What time's our lesson on Wednesday?
3:30.
3:30. So if the quiz started at 3:30, I'd say, okay, we start the quiz at 3:30. At 4 o'clock, we'll start the lab. Anybody that finishes before 4 o'clock, go. You can't stay in the room. Would you be agreeable to that? Otherwise, what we do is we do the lab first, and then we do the quiz at the end, and you just leave when you're finished.
I'm okay with the first option.
Raneem likes the first one. You guys talk about it a bit. We can decide next lesson. Okay. So I think I'm done now. If you want to make sure that you've signed, that'd be good. If you've got any questions, I'm here to answer your questions. Otherwise, you can go.
Thank you, sir.
Thanks, Raneem. Thanks. I'm good, thanks, Abdullah. Afif, how are you?
The tutorial should we do it on the computer or like in the stick phone? Because I think we already did it in the last week.
Yeah, but we did it in the past week, but we didn't do it with a function. The difference is it's the same code almost, but it's with a function. So yeah, just come have a look at how we do it in the function. It's a little bit different.
So it's not the same.
Oh, here, I'll show you. Since you're asking, running out of time. Oh, I got to finish the program. So somebody's out there. Yeah, let's end this.